Welcome everyone to this live podcast on Twitch where you can get the new news from the research industry that how our researchers keep on researching on various topics and domains so to keep our lifestyle more better and more sustainable of course. And yes, this article is posted on our website named postscientist.com. If you are willing to check it out, please check it out. Otherwise, listening to this podcast will be enough for you guys as it's act like an archive on the daily basis, providing you the information from the research industry. So let's get started without wasting any further time. The first topic of the day is wobbling black hole most extreme example ever detected. Researchers at Cardiff University have identified peculiar twisting motion in the orbits of two colliding black holes, an exotic phenomenon predicted by the Einstein theory of gravity. The study, which is published in Nature and led by Professor Mark Hunnam, Dr. Charlie Hoy, and Dr. Jonathan Thompson, reports that this is the first time this effect, known as precession, has been seen in black holes, where the twisting is 10 billion times faster than in previous observations. The binary black hole system was found through gravitational waves in early 2020 in the advanced LIGO and Virgo detectors. One of the black holes 40 times bigger than our sun is likely the fastest spinning black hole to be found through gravitational waves, and unlike all previous observations. The rapidly revolving black hole distorted space and time so much that the binary entire orbit wobbled back and forth. This form of precision is specific to Einstein's theory of general relativity. This result confirms its existence in the most extreme physical event we can observe, the collision of two black holes. We have always thought that binary black holes can do this, said Professor Mark Hunnam of Cardiff University Gravity Exploration Institute. We have been hoping to spot an example ever since the first gravitational wave detections. We had to wait for 5 years and over 80 separate detections, but finally we have one. A more down to earth example of precision in the evolving of a spinning top which may wobble or precess once every few seconds. By contrast, precision in general relativity is usually such a weak effect that it is imperceptible. In the first example previously measured from orbiting neutron stars called binary pulsars, it took over 75 years for the orbit to precess. The black hole binary in the study, clo- colloquially known as GW 200 129, named after the date it was observed, January 29, 2020. Process several times every second and affect n billion times stronger than measured previously. Dr. Jonathan Thompson, also a Cardiff University, explained it is a very tricky effect to identify. Gravitational waves are extremely weak and detected to them. It requires the most sensitive measurement apparatus in history. The precision in is an even weaker effect buried inside the already weak signal, as we had to do a careful analysis to uncover it. Gravitational waves were predicted by Einstein in 1960. That was the first directly detected from the merger of two black holes by the advanced LIGO instruments in 2015, and breakthrough discovery that led to the 2017 Nobel Prize. Gravitational astronomy is now one of the most vibrant fields of science, with a network of the advanced LIGO, Virgo, and Kagra detected operating in the US, Europe, and Japan. To date, there have been over 80 detection, all of merging black holes or neutron stars. So far, most black holes we have found with the gravitational waves have been spinning fairly slowly, said Dr. Charlie Ho, a researcher at Cardiff University during this study and now at the University of Portsmouth. The larger black hole in this binary, which was about 40 times more massive than the Sun, was spinning almost as fast as physical possible. Our current models of how binary forms suggest this one was extremely rare, maybe a 1 in 1000 event, or it could be a sign that our models need to change. The International Network of Gravitational Wave Detector is currently being upgraded and will start its next search of the universe in 2023. They are likely to find hundreds of more black holes colliding and will tell scientists whether GW 20129 was a rare exception or a sign that our universe is even stranger than they thought. Of course, of course. Moving on to our next topic. Physicists probe astonishing morphing properties of honeycomb like material. Okay. A series of buzzing bee like loop currents could explain a recently discovered, never before seen phenomena in a type of quantum material. Okay. The finding from researcher at the University of Colorado Boulder may one day help engineers to develop new kinds of devices such as quantum sensor or the quantum equivalent of computer memory storage devices. The quantum material in a question is known by the chemical formula Mn3Si2T6, but you could also call it honeycomb because its manganese and tellurium atom form a network of interlocking octahedra octahedra that look like the cells in a beehive. Physicist Gang Xiao and his colleague C.U. Boulder synthesized this molecular beehive in their lab in 2020, and there were in for a surprise. Under more circumstances, the material behaved a lot like an insulator. In other words, it didn't allow electric currents to pass through it easily when they exposed the honeycomb to magnetic field in a certain way. However, it certainly became millions of times less resistant to current. It was almost as if the material had moved from rubber into metal. It was both astonishing and puzzling, said Cow, professor in the Department of Physics and corresponding author of the new study. Our follow-up effort is pursuing a better understanding of the phenomenon led us to even more surprising discoveries. Now he and his colleagues think they can explain that astonishing behavior. The group, including several graduate students at CE World, published its most recent result on November 17 in the journal Nature. Drawing on experiment in Cow's lab, the group reports that under certain conditions, the honeycomb is a bus with tiny internal currents known as uh, chiral orbital currents or loop currents. Electrons zip around in loops within each of the octahedra in this quantum material. Since the 1990s, physicists have theorized that loop currents could exist in a handful of known materials, such as high temperature superconductors, but they have yet to directly observe them. Cow said they could be capable of driving startling transformation in quantum materials like the one he and his team stumbled on. We have discovered a quantum state of matter, Cow said. Its quantum transition is almost like ice melting into water. Oh, okay. So, these are the results given by our physicist on the honeycomb like material, of course, using in many other applications. He is talking about the quantum sensor and the quantum computer memory storage devices. So, yep, I mean, it's going to be used more like in quantum computer application or sensor, whatever it is. I mean, like it's used like as a storage, as a bit, not as a bit, of course, but in a part of the system. Okay. Moving on to our next topic, dust plumes observed being pushed into interstellar space by intense starlight. Astronomers have observed directly for the first time how intense light from stars can push matter. Researchers from the University of Cambridge and Sydney made the observation when tracking a giant plume of dust generated by the violent interaction between two massive stars. The result made use infrared images of the binary star system. WR140, taken over 16 years, are reported in the journal Nature. In a complementary study of WR140 published in Nature Astronomy, NASA James Webb Space Telescope (JWST) was able to see much deeper to snap an image of not just a single accelerating dust plume, but almost 20 of them, nested inside each other like a giant set of onion skins. Of course. WR140 is a comprised of a huge Rayet star and an even bigger blue supergiant star, gravitationally bound in an 8-year bid. This binary star in Cygnus constellation has been monitored for 2 decades with one of the world's largest optical telescope of the Observatory in Hawaii. WR140 is comprised of a huge Wolf-Rayet stars and an even bigger blue supergiant star gravitationally bound in an 8-year bid. This binary star in the Cygnus constellation has sorry guys, sorry, really sorry guys. WR140 absurdly pops out plumes of dust stretching thousands of times the distance from the Earth to the Sun. These dust plumes produced every 8 years give astronomers a unique opportunity to observe how starlight can affect matter. It's known that light carries momentum, exerting a push on matter known as radiation pressure. Of course, astronomers often witness the outcome of this phenomenon in the form of matter coasting at high speed around the cosmos, but it's been a difficult process to catch in the act. Direct recording of acceleration due to forces other than gravity is rarely witnessed, and never in a stellar environment like this. It's hard to see starlight causing acceleration because the force fades with distance and other forces quickly take over, said Yunwa Hang from Canadian Institute of Astronomy, first author of the Nature paper. To witness acceleration at the level that it becomes measurable, the material needs to be reasonably close to the star, or the source of radiation pressure needs to be extra strong. WR140 is a binary star whose function radiation field supercharges these effects, placing them within reach of our high precision data. All stars generate stellar winds, but those from Wolf-Rayet stars can be more like a stellar hurricane. Elements such as carbon in the wind condense out as soot, which remains hot enough to glow bright in the infrared like smoke in the wind. This gives telescopes something that can be observed. The team used an imaging technology known as interferometry, which was able to act like a zoom lens for the 10-meter Keck telescope mirror, enabling the researcher to recover sufficiently sharp images of WR140 for the study. Hand and his team found that the dust does not stream out from the star with the kind in a hazy ball. Instead, the dust forms where the winds from the two stars collide on the surface of a cone-shaped shock front between them. Because the orbiting binary star is in constant motion, the shock front also rotates. The sooty plume gets wrapped into a spiral in the same way that droplets from a spiral in a garden sprinkler. The researcher found that WR140 has other tricks up its sleeve. The two stars are not on circular but rather elliptical orbits, and dust production turn on and off as the binary nears and departs the point of closest approach. By modeling these effects into the three-dimensional geometry of the dust plume, the astronomers were able to measure the location of dust features in three-dimensional space. Like clockwork, these star puffs out sculpted smoke rings every 8 years. With all this wonderful physics written, then inflated in the wind like a banner for us to read, said co-author Professor Peter Tuthill. from the University of Sydney. 8 years later, as the binary returns in its orbit, another appeared the same as the one before, streaming out into space inside the bubble of the previous one, like a set of giant nested Russian dolls. Because the dust produced by this Wolf Rayet is so predictable and expand to such large distances, it offered the astronomers a unique laboratory to examine the acceleration zone. In the absence of external forces, each dust spiral should expand at a constant speed, said Han, who is also a co-author on the JWST paper. We were puzzled at first because we could get our not get our model to fit the observations until we finally realized that we are seeing something new. The data did not fit because the expansion speed wasn't constant, but rather that it was accelerating. We did caught that for the first time on camera. In our sense, we always knew this must be the reason for the outflow, but I never dreamed we did. We also to see the physics at work like this, said Turtle. When I look at the data now, I see WR-140 plumes unfurling a like giant sail mud of dust when it catches a photon wind streaming from the star like a yacht catching a gust. It makes a sudden leap forward. With JWST now in operation, researcher can learn much more about WR-140 and similar systems. The Webb telescope offered new extreme of stability and sensitivity, said Ryan Lau, who led the JWST study. We will now be able to make observation like this much more easily than from the ground, opening a new window into the world of Wolf-Rayet physics. Of course. Moving on towards the next topic, scientists demonstrate that electricity may be obtainable from water with a high salt concentration. Okay. Devising renewable source of energy is a key concern for scientists, political leaders, and community as the world comes to terms with the realities of climate change and the limits of the Earth's natural resources. In an exciting new development, scientists from the Institute of Scientific and Industrial Research, SUNCAN, at Osaka University have demonstrated that electricity may be obtainable from water with a high salt concentration such as seawater. Some people think about osmosis as just a science term they were forced to learn in elementary school biology class. However, the spontaneous motion of dissolved ions or molecule through a semi-permeable membrane, when there is a concentration difference between two sides, can be harnessed to generate electricity. And luckily for us, the ocean are filled with salty water, which may be used to help alleviate humanity ever-growing demand for energy. However, in order to be practical, this membrane needs to be very thin and highly selective to allow ions, but not water molecules, to pass through. Now, a research team led by Osaka University had used conventional semiconductor processing technology to precisely control the structure and arrangement of nanopores in an ultra-thin silicon membrane. Because this fabrication method have been around for decades, the cost of design complexities were minimized. Moreover, the size and location of the pores could be precisely controlled. Whenever there is non-equilibrium situation, such as two water tanks with different salt concentration, there is often an opportunity to convert this thermodynamic energy into electricity, said first author Mukusu Tutsu. Using a single 20 nanometer size nanopore, the device reached a peak powered efficiency of 400 kilowatt per meter squared. However, the researcher found that adding too many nanopores to the membrane actually reduced the power that could be extracted. The optimal configuration of pores, 100 nanometer size nanopores arranged in a grid with a spacing of 1 micrometer, yielded an osmotic power density of 100 watt per meter squared. This was an important step in understanding how to design nanopore device for best power generation. Many Other research groups are promising environmentally friendly green energy, but we go one step further and propose blue energy based on ocean water that can be applied on an industrial scale. Senior author Tomoji Kawai says the study is published in the Cell Report Physical Science, and future projects may include ways to scale up the device for real world testing. Okay. So it's scientists try to demonstrate those things that can obtain electricity from water itself with a high salt concentration in the water. So, yep, these are the results given by our scientists. Okay, moving on to our next topic. Researchers identify brain regions where word meaning is retrieved. Okay. A new study by researchers at the Medical College of Wisconsin MCW reveals the area of the brain where the meanings of words are retrieved from memory and processed during language comprehension. Previous neuroimaging studies had indicated that large portion of the temporal parietal and frontal lobes participate in processing language meaning, but it was unknown which regions encoded information about individual word meanings. We found that word meaning information was represented in several high level cortical areas, that is, area that are not closely connected to primary sense or motor areas, including the classical language areas known as Broca area and Brinskin area, said Dr. Leonardo Fernandino, assistant professor of neurology and biomedical engineering at MCW. Interestingly, however, some regions not precisely previously considered as important for language processing were among those containing the most information about word meaning. Additionally, they also investigated whether the neuro representation of word meaning in each of these areas contain information about phenomenological experience that is related to different kinds of perceptual, emotional, and action related experiences. As several researchers had previously proposed, or whether they contain primarily information about conceptual category that is natural kinds, or about word co-occurrence statistics, as other researchers have theorized. They use functional MRI along with a technique called representational similarity analysis (RSS) searchlight mapping to generate a high resolution map of the brain region in which word meaning information was activated. When participants were slightly reading individual words presented on the screen, a different word was presented every few seconds. They scanned 64 participants across two different experiments. The words were all English nouns, including animal found, plants, tools, vehicles, body parts, human trait, quantities, social events, verbal events, sound events, and negative events. As expected, they found that word meaning was represented in both cerebral hemispheres, although the left hemisphere was more prominently involved. In most people, the left hemisphere is specialized for language processing, while the right hemisphere specializes in processing visual spatial information. We also found that the word meaning representation in all of the region encode experiential information, that is, information derived from sensory, motor, and emotional experience, even after controlling for other types of information such as semantic category and word co-occurrence statistics, said Dr. Fernandino. The study also showed that these representations are multimodal in that they combine information from multiple features of experience and from multiple sensory modalities. The researcher found that the brain areas known as the default mode network, which act as connection hubs for neural pathways originating in the visual, auditory, tactile, motor, and other modality specific areas, were among the most important areas for processing word meaning, which supports the previously published proposal of a hierarchy system of the convergence zones for concept representation. The study is published in the Nature of Neuroscience. Hmm. Okay. 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 So basically, it's providing you the result from the uh, neuroscience topic. So yep. Moving on to our next topic. It's not going to the next topic. It's more likely a news. So let's see. A report which being which we are going to read it out. Okay. People in the UK have higher probabilities of dying than predicted. New report finds many men and women in the UK have a higher probability of dying than predicted. A new report has found the result published in European Actual Journal could have a big impact on the future viability of pension schemes. The researcher from Bayes Business Schools, which looks at the death rates for people aged 50 to 95, paints a bleak picture for men and women in the UK. Examination of 21 high income countries over a period of 50 years analyzed the patterns of death rates between 1960 and 2010 and then explored whether what has happened since 2010 followed the predicted patterns. The data shows that following data of improvement in the probability of dying and in life expectancy since 2011, the probability of dying for people in the UK are higher than forecast based on the earlier trends. There is also marked difference in gender. It is most starkly shown in UK women, whose average improvement in the probability of dying has fallen from 22.1% a year 2000 to 2010 to 0.84% 2011 to 2017. In UK men, the improvement rate is the lowest it has been in almost 40 years, 1.18% since the 1980s. The data shows a trend in death rates among women that was worse than expected in 19 of the 21 analyzed countries. One of the 21 countries examined, the UK, ranked 17 worst for the women and 19 worst for men. Co-author Professor Stephen Harburn of Bayes Business School says these negative trends in the UK may be attributed these to the negative consequences of the government austerity policies after the 2008 recession and higher than normal levels of winter deaths. Professor Haberman, a professor of actual science, believes the finding pose an alarming, alarming trend and have a sizable societal implication. Following this, the proposal to increase the state pension age from 65 to 68 by 2046. If the rates of mortality improvement are lower, it means that state pension, private pensions, and annuities are cheaper to fund. This means, for example, that defined benefit pension schemes like USS are probably in a better financial situation than expected, he states. That has implication because it is a government policy to increase the state pension age on the basis that people are living longer, but this might not now be the case. We might be making people work for longer, then be faced with a shorter time in retirement to enjoy our pension. So as the retirement age has been pushed up too quickly, the answer may be yes, he observes. Other findings from the report shows that the speed of mortality rates improving in Denmark are significantly ahead of the rest of Europe. Additionally, the mortality improvement rates of women in Greece, Italy, and the Netherlands were noticeable worse on average after 2010 than other countries, for example, worse than France, Germany, and the UK. The countries in which men's mortality rates are improving most noticeably are Norway, Denmark, Ireland, and Belgium. Although it is a more balanced trend than in women, the picture is different from men in the UK, Italy, and Germany, who have shown in the slowest improvements in Europe. Okay, so these are the findings. These are the studies given by given by our researchers, not the scientists. Yes. by the researcher who give this possibilities. Okay, moving on towards next topic. Typo swipe, an image recognition tool to detect typo squatting attacks. Okay. In recent decades, cyber attacks have been increasingly varied, introducing various strategies to lure users onto malicious websites or prompt them to share sensitive data. As a result, computer scientists are continuously trying to develop more advanced tools to detect and neutralize these attacks. Typo squatting, one of the most common attacks carried out online, exploits the human tendency to misspell words when typing quickly or to misread words when they have small topographical errors. Typo squatting essentially consists in the creation of malicious websites with URLs that resemble established sites but with slight typos. Example: FQCE book, okay, fix book instead of Facebook, or YouTube YUUBE instead of YouTube. Whenever mistakenly visit these websites, they might unwillingly download malware or end up sharing personal information with the attackers. Of course, most exciting technique for detecting these phishing attacks are based on spell checking tools. While these tools can work in some instances, they do not generalize well as their performance typically depends on the vocabulary of words used to train them. Researchers at Ensign Infosecurity and end-to-end cybersecurity service provider based in Singapore have recently created Typo Swipe, an alternative tool for detecting typo squatting attacks that is based on the analysis of images. This tool, introduced in a paper pre-published or on ARZiv, uses advanced image recognition techniques to convert strings into images that also consider the location of letters on the keyboard. Typo squatting makes use of typographical errors of typos. Example: google.com instead of google.com. It's a google.com instead of google.com to mislead user to access unwanted website. David Yam, one of the researchers who carried out the study, told TechExplore current techniques to tackle these phishing attacks utilize string at distance which do not depend on the keyboard character position. G is found in a different keyboard area from Z, and hence are less accurate in catching typos. Example: google.com and google.com is equally far apart from google.com. Of course, we utilize image recognition techniques such as convolutional neural network CNN and a specific loss function to improve on typo squatting detection. Right. In contrast with other methods for detecting typo squatting introduced in the past, typo swipe can capture the distance between different characters on the keyboard by tracing lines between the buttons of consecutive characters on an imaginary keyboard. This helps to reduce errors. That exciting string added distance matrix, that is method that conclude how dissimilar two words or character sequence are from each other are prone to making. We utilized image recognition technique because it can batch process multiple possible typo squatted domains at one shot, enabling faster processing as compared to string matching solutions. Lee explained also utilizing swipe inputs allows us to visual inputs which are likely to be the typo squat of each other, such as Facebook and Facebook. Yam and his colleagues Lee, Jenan, Jun, Son evaluated their typo squatted detection tool in a series of tests, comparing its performance with that of the DLD algorithm, a widely used cybersecurity model. They found that typo swipe could detect typo squatting more reliably than DLD, while also accurately identifying the well established and safe domains that attackers were trying to copy or typo squat. Hmm. Typo swipe is, to the best of our knowledge, the first application of CNNs to tackling typo squatting using swipe inputs. Yam said, using swipe inherently captures the keyboard distance metric that typographical errors usually have. We also have a triplet loss and anti-cent loss as superior mechanism to train our model because it provides a minimum boundary between non-similar swipe images. This enables us to improve matrix F1 scores in detecting typo squatting domains that are already fairly similar one added distance away by string added distances matching algorithms. The recent work by this team of researchers could soon inspire the development of other cybersecurity techniques based on image recognition models. Meanwhile, typo swipe will be included with the Ensign Info security suite of phishing detection tools, making it available to users worldwide. Of course. So these are the uh, given the tool which is based on the typo squad, uh, focusing on the typo squad or type of attacks, or like a mismatching attack which will indirectly uh, the user can indirectly give the information to the attacker itself by this type of squatting techniques. Mistake mistakenly, of course, but of yes, these are the cybersecurity tool which is being discovered by the single researcher or scientist, whatever. Yes, researchers or and the computer scientific experts, of course. So, yep. Moving on to our next topic, code tune, a tool to automatically create stories and comics. Okay, let's see. Interesting. Three researchers at University of Waterloo in Canada have recently developed a unique comic authoring tool that can automatically create stories and comics based on code. This system called Code Toon could open interesting possibility for code-driven storytelling, the process of using computation code to create new stories. Swang Wang Su, one of the authors, came up with the idea of Code Toon and then worked on its development in collaboration with his colleague Jian Zhao under the supervision of Professor It Law. The paper is said to be presented in a few weeks at the ACM Symposium on User Interface Software and Technology UIST, the premier forum for innovation in human computer interfaces, builds on some of their team previous efforts, including the development of a pedagogical tool called Coding Strip. Another study leveraging generating conversational AI to teach computational thinking. Okay. We have found that using comics is an effective means for teaching abstract programming concepts, but crafting the comics is tedious and time consuming. Of course. Jian Zhang, one of the researchers who carried out the study, told at Tech Explore, who also identified the opportunity in advanced AI technologies for automating some steps of this task. Thus, we built CodeToon, a comic authoring tool that facilitates this code-driven storytelling process. Coding Strip, the pedagogical tool previously created by Songhua Zhu and his colleagues at University of Waterloo, was specifically designed to teach programming concept using comics. Cartoon takes this idea one step further by automatically creating coach-based comics and stories that could be used to train computer science students, inspired by the ladder of abstraction and its relationship to computational thinking. Coding strip help learners move between concrete comic and abstract code levels of abstraction Sangwa Su, one of the researchers who carried out the study, told Tech Explore creating coding strip, however, can be time consuming and laborious, so the primary objective of this project was to make the authoring process more efficient and effortless. Cartoon can facilitate code-driven storytelling in two distinct ways. First, it can automatically generate a story template using code. Subsequently, the tool can generate comics based on the code-based story templates. Cartoon is an interactive and intelligent comic authoring tool that supports creators to generate story from code into story, and design comic from story into comic. Zhao and Zhu said, since comic accurately represent the code semantics and execution process, it enables learners to learn the computational concepts and procedures in an engaging yet effective manner. The researcher evaluated the effectiveness of the comic authoring tool in a two-part user study. In the first part, 24 participants with a basic understanding of programming were asked to either use cartoon or use a series of templates to create a story ideas and generate matching comics. Subsequently, all the participants took part in a short interview where they were asked what worked and what didn't work for them. In the second part of the evaluation, 20 participants who could read and understand Python code were asked to look at coding eight coding strips created using Cartoon or with a series of templates and shared their opinions about how well they mapped into code, illustrated coding concepts, and how useful they thought they might be for teaching. Based on the interview responses, most participants felt that one-to-one mapping of code onto stories and comics could be an effective teaching strategy, particularly when using comics to alternatively represent code. In addition, those who used Cartoon to generate these comics shared positive feedback about its performance in creating code-based stories and comics, are finding confirmed previous literature on multiple representational system which recommends making the mapping between multiple representation clear. Zhao said. Art Insight also shed light on the other research areas such as data and state comics, which can also leverage this approach to automatically generate comics for learning and technique, teaching concept in their domains. Notably, Zhou and Lo introduced a new way of looking at code that could have interesting implications. In the future, the same idea could perhaps be applied to other computational and mathematical languages. For instance, future studies could explore the possibility of generating comics and stories based on mathematical equations. The most notable achievement of our study on the surface may be the efficient process for generating comics from code, Sue said. But on a deeper level, I think it is the notion of code driven storytelling. In cartoon, code drives storytelling, the code's abstract structure, embodying computational ideas such as if else logic structure because becomes the structure of the story and comic. In other words, code determines the sequence and overall plot of the story. The tool created by Siu Xiao and Law could soon be used in university and colleagues to make learning to code code more engaging. In the future, the researcher would thus like to deploy their tool in a real classroom environment to better access its usefulness. In addition, they plan to investigate the possibility of using generative deep learning models such as GPT-3 and Codex to fill any gaps in stories and code. For example, based on the drawings on the canvas, the system could generate new drawings to add to the existing comic and provide design guidance in real time, Xiao explained. Another possible research direction would be to enhance the authoring process with a more diverse set of sketches and comic resources, more customization and flexibility, as well as the support for more programming languages. In his upcoming studies, Seo would also like to investigate the possible use of mathematical language to drive storytelling. This could ultimately improve the way in which lecturers and students make sense of abstract concepts, complex equations, and procedures. There are many exciting research directions we plan to explore in our next studies. Zero added one is to further improve Code for example, by ensuring that it supports other programming languages and features. Another is to research how we can use Code to integrate art into programming education. Of course, so these are the, I mean, great project. So I, by my side, if you talk about my opinions on this, this is a interesting topic. I mean, it's a great project, of course. Pro, it can increase the comic production. It can increase more in the formation of anything. Like we traditionally read mangas or any other comic books, which we normally do, and but we still have a concept in the mind. More likely to see web series, or more likely to many more things through picturization, and analyze things through those things. And yes, he also include that it can learn the most simple concept of the code into through these comics. So I mean, it's it's been used in various domains, of course, in education purpose, or through entertainment purpose, of course, and many other domains. But still, if i I mean, it's more likely successful in the educational purpose only, because otherwise it's not like we are creating a character, or defining the characteristics of it and everything. And as we are developers, or as we all know, if you are going to talk about developer, that what you're looking into this comic, or having understand those things. So I mean, for understanding or education purpose or information based purpose, it will be easy for us to understand and memorize it in our brain, of course. But still, these things not going to compare with the old manga tools or the old manga comics which I am talking about. Uh, any 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 of the people who are traditionally reading those comics in a way, like I mean, a super fan of it, or yeah. So it's like that. It's more likely. Well, I mean, I'm more. I'm very happy to have this thing, because I am also one of the. I mean, I draw some. I'm also doing some of the characteristics, or making a character through my tablet or through my laptop. But for understanding, of course, for the understanding, for understand the other topics to other self, or to a person, which is easily be understand through a character. Of course, we need to give some of the examples. So it's more likely, if it's a character is talking about, then the person or the children um, will understand more better, more efficiently. So yep, I mean, great, great project. They deserve it. So yep. Moving on to our next topic. Smart plastic material, a step forward towards soft, flexible robotics and electronics. Okay. Inspired by living things from trees to shellfish, researchers at the University of Texas at Austin set out to create a plastic much like many life forms that are hard and rigid in some places and soft and stretchy in others. Their success forced using only light and a catalyst to change properties such as hardness and elasticity in molecules of the same type has brought about a new material that is 10 times as tough as natural rubber and could lead to more flexible electronics and robotics. The findings are published today in the journal Science. This is the first material of its type, said Zaria Page, assistant professor of chemistry and corresponding author on the paper. The ability to control crystallization and therefore the physical properties of the material with the application of light is potentially transformative for variable electronics or actuators in soft robotics, of course. Scientists have for a long sought to mimic the properties of living structures like skin and muscle with synthetic materials. In living organism structure often combine attributes such as strength and flexibility with ease. When using a mix of difficult synthetic material to mimic these attributes, material often fail, coming apart and ripping at the junctures between different materials. Oftentimes, when bringing material together, particularly if they have a very different mechanical properties, they want to come apart. Page said Page and his team were able to control and change the structure of a plastic-like material using light to alter how firm or stretchy the material would be. Chemists started with a monomer, a small molecule that binds with others like it to form the building block for larger structure called polymers that were similar to the polymer found in the most commonly used plastic. After testing a dozen catalysts, they found one that, when added to the monomer and shown visible light, resulted in a semi-crystalline polymer similar to those found in existing synthetic rubber. A harder and more rigid material was formed in the areas the light touched, while the unlit areas retained their soft, stretchy properties. Because the substance is made of one material with different properties, it was stronger and could be stretched further than most mixed materials. The reaction take place at room temperature. The monomer and catalyst are commercially available, and researchers use an inexpensive blue LEDs as the light source. In the experiment, the reaction also take less than an hour and minimizes use of any hazardous waste, which makes the process rapid, inexpensive, energy efficient, and environmentally benign. The researcher will next seek to develop more objects with the material to continue to test its usability. We are looking forward to exploring method of applying this chemistry towards making 3D objects containing both hard and soft component, said a first author Adrian Reliski, a doctoral student at UT Austin. The team envisions the material could be used as a flexible foundation to anchor electronic component in a medical device or variable tech. In robotics, strong and flexible materials are desirable to improve movement and durability. Henry L. Carter, Keldy S. Mason, Marshall J. Allen, Anthony J. Arrowwood, Benny D. Freeman, and Gabriel E. Sonoja of the University of Texas and Austin also contributed to the research. Okay, okay. So, I mean, yeah. So these are uh, moving towards next topic. New measurements quantifying qubits provide glimpse of quantum future. Okay, okay, okay. Using existing experimental and computational resource, a multi-institutional team has developed an effective method for measuring high-dimensional qubits encoded in quantum frequency combs, which are a type of photon source on a single optical chip. Although the word qubit might look like a typo, this lesser known cousin of the qubit or quantum bit can carry more information and is more resistant to noise, both of which are key qualities needed to improve the performance of quantum networks, quantum key distribution system, and eventually the quantum network, quantum internet. Okay. Classical computer bit characterize data as 1 or zeros, whereas qubits can hold values of 1, 0, or both simultaneously, owing to superposition, which is a phenomenon that allows multiple quantum states to exist at the same time. The D in qubits stands for the number of different levels or values that can be encoded on a photon. Traditional qubits have two levels, but adding more level transform them into qubits. Recently, researchers from the U.S. Department of Energy, Oak Ridge National Laboratory, Purdue University, and the Swiss Federal Institute of Technology Lausanne, or EPFL, fully characterized an entangled pair of 8-level qubits, which formed a 64-dimensional quantum space quadro pulling the previous record for discrete frequency modes. These results were published in Nature Communication. We have always known that it's possible to encode 10 or 20 level qubits or even higher using the cloud of photons or optical frequency, but the problem is that measuring these particles is very difficult, said Hunsun Hao Lu, a postdoctoral research associate at OR Annal. That's the value of this paper. We found an efficient and novel technique that is relatively easy to do on the experimental side. Qubits are even more difficult to measure when they are entangled, meaning they share non-classical correlations regardless of the physical distance between them. Despite these challenges, frequency bin pairs, two qubits in the form of photons that are entangled in their frequency, are well suited to carrying quantum information because they can follow a prescribed path through optical fiber without being significantly modified by their environment. We combine state-of-the-art frequency bin production with the state-of-art light sources, and then use our technique to characterize high-dimensional qubit entanglement with a level of precision that hasn't been shown before, said Joseph Lukens, a Winger Fellow and research scientist at ORNL. The researcher began this experiment by shining a laser into a micro ring resonator, a circular on chip device fabricated by EPFL and designed to generate non classical light. This powerful photon source, taken up 1 square millimeter of space, comparable in size to the point of sharpened pencil, and allowed the team to generate frequency bin pairs in the form of a quantum frequency comms. Typically, qubit experiments require researchers to construct a type of quantum circuit called a quantum gate, but in this case, the team used an electro-optic phase modulator to mix different frequency of light and a pulse sharper to modify the phase of this frequency. These techniques are studied extensively at the ultrafast optic and optical fiber communication laboratory led by Andrew Wiener at Purdue, where Lou studied before joining ORNL. These optical devices are commonplace in the telecommunication industry, and the researcher performed this operation at random to capture many different frequency correlation. According to Lou, this process is like rolling a pair of six-sided dice and recording how many times each combination of numbers appears. But now the dice are entangled with each other. This technique, which involves phase modulator and pulse shapers, is heavily pursued in the classical context for ultrafast and broadband photonic signal processing and has been extended to the quantum avenue of frequency qubits, Wiener said. To work backward and infer which quantum state produce frequency correlation ideal for qubit application, the researcher developed a data analysis tool based on a statistical method based called Basin interface and ran computer simulation at ORNL. This accomplishment builds on the team previous work focused on performing Basin analysis and reconstructing quantum states. The researchers are now fine-tuning their measurement method to prepare for a series of experiments by sending signals through optical fiber. They aim to test quantum communication protocols such as teleportation, which is a method of transporting quantum information, and entanglement swapping, which is the process of entangling two previous unrelated particles. Karthik Milswamy, a graduate student at Purdue, plans to bring the micro-ring resonator to ORNL, which will enable the team to test these capabilities on the Levity Quantum Local Area Network. Okay. Now that we have a method to efficiently characterize entangled frequency qubits, we can perform other application-oriented experiments, Milswamy said. Of course, right. Moving on towards next topic. NASA Swift NASA Swift and Fermi missions detect exceptional cosmic blast. Astronomers around the world are captivated by an unusual bright and long lasting pulse of high energy radiation that swept over Earth on Sunday, October 9th. The emission came from a gamma ray burst, GRB, the most powerful class of explosions in the universe that ranks among the most luminous events known. On Sunday morning Eastern Time, a wave of X-rays and gamma rays passed through the solar system, triggering detectors aboard NASA Fermi Gamma Ray Space Telescope, Neil Gehrels Swift Observatory, and Wind spacecraft, as well as others. Telescopes around the world turned to the site to study the aftermath, and new observation continue called GRB 2209A. The explosion provided an unexpectedly exciting start to the 10th Fermi Symposium, a gathering of gamma ray astronomers now underway in Johannesburg, South Africa. It's safe to say this meeting really kicked off with a bang. Everyone talking about this, said Judy Ruckinson, a Fermi deputy project scientist at NASA Goddard Space Flight Center in Greenbelt, Maryland, who is attending the conference. The signal originating from the direction of the constellation Sagitta had traveled an estimated 1.9 billion years to reach Earth. Astronomers think it represents the birth cry of a new black hole. Okay, one that formed in the heart of a massive star collapsing under its own weight. In these circumstances, a non-set black hole drives powerful jets of particles traveling near the speed of light. The jet passes through the star, emitting X-rays and gamma rays as they stream into space. The burst also provides a long-awaited inaugural observing opportunity for the link between two experiments on the International Space Station, NASA NICER X-ray telescope, and a Japanese detector called the Monitor of All Sky X-ray Image (MAXI). Activated in April, the connection is dubbed the Orbiting a High Energy Monitor Alert Network. OMAN, it allows NICER to rapidly turn to outbursts detected by MAXI action that previously required intervention by scientists on the ground. Oman provided an automated alert that enabled NICER to follow up within 3 hours as soon as the source became visible to the telescope, said Zeven Arzumanian, the NICER science lead at Goddard. Future opportunity could result in response times of a few minutes. The light from this ancient explosion brings with its new insights into stellar collapse, the birth of a black hole, the behavior and interaction of matter near the speed of light, the condition in a distant galaxy, and much more. Another GRB this bright may not appear for decades. According to preliminary analysis, Fermi Large Area Telescope LAT detected the burst for more than 10 hours. One reason for the burst brightness and longevity is that for a GRB it lies relatively close to us. This burst is much closer than typical GRBs, which is exciting because it allows to detect many details that otherwise would be too faint to see, said Roberta Pileda, a Fermi-led collaboration member who led initial communication about the burst and a doctoral student at the Polytechnic University of Bari, Italy. But it's also among the most energetic and luminous bursts ever since, regardless of distance, making it doubly exciting. Okay, moving on towards next topic. NASA Lucy spacecraft prepares to swing by Earth. Okay, I mean, let's read it and understand it what's the news is. On October 16 at 7:04 a.m. EDT, NASA Lucy spacecraft, the first mission to the Jupiter Trojan asteroids, will skim the Earth atmosphere, passing a mere 20 220 miles, 350 kilometers above the surface by swinging past Earth. On the first anniversary of its launch, Lucy will gain some of the orbital energy it's need to travel to this never before visited population of asteroids. The Trojan asteroids are trapped in orbits around the Sun at the same distance as Jupiter, either far ahead or of or behind the giant planet. Lucy is currently 1 year into a 12-year voyage. This gravity assist will place Lucy on a new trajectory for a 2 year orbit, at which time it will return to Earth for the second gravity assist. The second assist will give Lucy the energy it needs to cross the main asteroid belt, where it will observe asteroid Donald Johnson and uh, then travel into the leading Trojan asteroid swarm. There, Lucy will fly past six Trojan asteroids, Euribates, and asteroid Kyoto, Polymele, and its yet unnamed satellite, Leucis and Oris. Lucy will then return to Earth for a third gravity assist in 2030 to retarget the spacecraft for a rendezvous with the Particulus Menotius binary asteroid paired in the trailing Trojan asteroid swarm. For their first gravity assist, Lucy will appear to approach Earth from the direction of the Sun. While this means that observers on Earth will not be able to see Lucy in the days before the event, Lucy will be able to take images of the nearly fully Earth and Moon. Mission scientists will use these images to calibrate the instruments. Lucy's trajectory will bring the spacecraft very close to Earth, lower even than the International Space Station, which means that Lucy will pass through a region full of Earth orbiting satellites and debris. To ensure the safety of the spacecraft, NASA developed procedure to anticipate any potential hazard and, if needed, to execute a smaller maneuver to avoid a collision. The Lucy team has prepared two different maneuvers, says Cordile Adam, Lucy Deputy Navigation Team Chief from Kinetics X Aerospace in Simi Valley, California. If the team detects that Lucy is at risk of colliding with a satellite or piece of debris, then 12 hours before the closest approach to Earth. The spacecraft will execute one of these, altering the time of closest approach by either 2 or 4 seconds. This is also a correction, but it is enough to avoid a potential catastrophic collision. Lucy will be passing the Earth at such a low altitude that the team had to include the effect of atmospheric drag when designing this flyby. Lucy's large solar arrays increase this effect. In this original plan, Lucy was actually going past about 30 miles closer to the Earth, says Rich Burns, Lucy project manager at NASA Goddard Space Flight Center in Greenbelt, Maryland. However, when it became clear that we might have to execute this flyby with one of the solar arrays unlatched, we choose to use a bit of our fuel reserves so that the spacecraft passes the Earth at a slightly higher altitude, reducing the disturbance from the atmospheric drag on the spacecraft solar arrays at around 6:55 a.m. EDT. Lucy will first visible to observe on the ground in Western Australia 6:55 p.m. For the observers, Lucy will quickly pass overhead, clearly visible to the naked eye, for a few minutes before disappearing at 7:02 a.m. EDT as the spacecraft passes into the Earth's shadow. Lucy will continue over the Pacific Ocean in darkness and emerge from the Earth's shadow at 7:26 a.m. EDT. If the clouds cooperate, sky watchers in the western United States should be able to get a view of Lucy with the aid of binoculars. The last time we saw the spacecraft, it was being enclosed in the payload fairing in Florida, said Hal Levision, Lucy's principal investigator at the Southwest Research Institute, SWRI Boulder, Colorado office. It is an exciting that we will be able to stand here in Colorado and see the spacecraft again, and this time Lucy will be in the sky. Lucy will then rapidly recede from the Earth's vicinity, passing by the moon and taking a few more calibration images before continuing out into interplanetary space. I am especially excited by the final few images that Lucy will take off the moon, said John Spencer, acting deputy project scientist at SWRI, counting craters to understand the collisional history of the Trojan asteroids is the key to the science that Lucy will carry out, and this will be the first opportunity to calibrate Lucy's ability to detect craters by comparing it to previous observation of the moon by other space missions. I mean, okay, so this is the spacecraft which being bring back to the Earth's atmosphere, hemisphere. Yep. Moving on towards next topic. Machine learning takes hold in nuclear physics. Okay. Let's see. Read it. Scientists have begun turning to new tools offered by machine learning to help save time and money. In the past several years, nuclear physics has seen a flurry of machine learning projects come online with many papers published on the subject. Now 18 authors from 11 institutions summarize this explosion of artificial intelligence aided work in machine learning in nuclear physics, a paper recently published in Reviews of Modern Physics. It was important to document the work that has been done. We really do want to raise the profile of the use of machine learning in nuclear physics to help people see the breadth of the activities, said Amber Burnwan, lead author of the paper and the associate director of for computational science and technology at the U.S. Department of Energy. Thomson Jefferson National Accelerator faculty. Because the paper gathers and summarizes major works in the field thus far, Burnham hopes it can act as an educational resource for interested readers as well as roadmap for future endeavors. It provides a benchmark that people can use as they can go forward into the next phase, she said, a machine learning revolution. After attending a workshop exploring artificial intelligence at Jefferson Lab in March 2020 and publishing a follow-up report, Burnman and two offered co-authored Witold Nerswatsky and Mikhail Kuchera were inspired to go a step further. Together with 15 colleagues representing all subfields of nuclear physics, they decided to conduct a survey of the state of machine learning projects in nuclear physics. They started at the beginning as the author described the first significant word employing machine learning in nuclear physics. Used a computer experiment to study nuclear properties such as atomic masses in 1992. Although this work hinted at machine learning potential, its use in the field remained minimal for more than 2 decades. In the first several years, that changed. Machine learning, which involves building models that can perform tasks without explicit instruction, requires computer to do specific things, including complicated calculation. With recent advances, computer can better meet these demands, which has allowed physicists to more readily incorporate machine learning into their work. This would have been a less interesting paper in 2019 because there wouldn't have been enough work to catalog, but now there is a significant work to cite due to the increased use of their techniques. Baldwin said today machine learning spans all scale and energy range of research, from investigation of matters building blocks to inquiries into the life cycle of stars. It also found across the four subfields of nuclear physics, theory, experiment, accelerator science, and operation and data science. We made an effort to compile a comprehensive collective resource that bridges the fields in our subfields, which will hopefully spark rich discussions and innovation across nuclear physics, said co-author Kuchera, who is an associate professor of physics and computer science at Davidson College. Machine learning models can be used to help both the design and execution of experiments in nuclear physics. They can also be used to aid in the analysis of the experiment's data, of which there is often in excess of petabytes. Petabytes. I expect machine learning to become embedded into our data collection and analysis. Kishida said machine learning will speed up these processes, which could mean less time and money is needed for beam time, computer usage, and other experimental costs. Connecting theory and experiment. So far, however, machine learning has developed the strongest foothold in nuclear theory. Nazar Viz, who is a nuclear theorist and chief scientist at the Faculty for Rare Isotope Beams at Michigan State University, is especially interested in the subject. He says that machine learning can help theorists to do advanced calculation faster, improve and simplify models, make predictions, and help theorists understand the uncertainties of their prediction. It can also be used to study phenomena that researchers cannot conduct experiments on, such as supernova explosion or neutron stars. Neutron stars are not even very user friendly, said Nesvaz. He used machine learning to study hyper heavy nuclei and elements which have so many protons and neutrons in their nuclei that they can't be observed experimentally. I find the result to be the most impressive in the theory community, particularly the low energy theory community. The Witold is associated with. Bonan said they seem to be really embracing these techniques. Bronland said theorists have also started to embrace these techniques at Jefferson Labs in their study of proton and neutron structure. Specifically, machine learning can help extract information from complicated theories, says a quantum chromodynamics, the theory that describes the interaction between the quarks and gluons that make up protons and neutrons. The author predicts that machine learning involvement in both theory and experiment will speed up these subfields independently, and it will also better interconnect them to speed up the entire loop of the scientific process. Nuclear physics help us make discoveries to better understand the nature of our universe. It also used for sh- societal application. Said Nazar Wiz, the faster we can do the cycle between experiment and theory, the faster we will arrive at discoveries and applications. As machine learning continues to grow in this field, the author expect to see more developmental and broader application incorporating this tool. I think we are only in the infancy of the application of machine learning to nuclear physics, Brundtland said, and along the way, this paper will act as a reference even for its own authors. I hope the paper is used as a resource to understand the current state of machine learning research, allowing us to build from these efforts, Kishida said. My research is centered on machine learning methods, so I absolutely will utilize this paper as a window into the state of machine learning across nuclear physics right now. Moving on towards next topic and the last topic of this podcast, new insights into how serotonin regulates behavior. Okay, let's see. Rates of anxiety and depression have been increasing around the world for decades, a trend that has been sharply exacerbated for the COVID 19 pandemic. New research led by the Beyonce Thompson Institute, Frank Schroeder, could ultimately lead to a new therapeutics to help relieve this global mental health burden. First discovered in the 1930s, serotonin is a neurotransmitter produced in many animals that mediates myriad behaviors such as feeding, sleep, mood, and cognition. Drugs that alter serotonin levels are the main weapon to treat psychological conditions like anxiety and depression, as well as eating disorders. As a simple model for neurobiology research, the microscopic roundworm cyan neurohaptids elegans has been used extensively to study serotonin role in regulating behavior and food intake. For many years, researchers thought that serotonin was made in C. elegans by one specific molecular pathway, and the serotonin was then quickly degraded. Schonder team and colleagues at Columbia University now demonstrated that both of these assumptions were not quite correct. We discovered a second, a parallel biosynthetic pathway that accounts for about half of the total serotonin produced in our model system, said Schroeder. The findings are described in a paper published in Nature Chemical Biology on October 10th. The work began about 3 years ago when the researcher unexpectedly discovered an enzyme that converts serotonin into derivative compounds. Most people in the field thought serotonin is made and then quickly broken down, but we found that instead it is used as a building block for other compounds that are responsible for some of the serotonin activities, explained Schroeder. So we decided to start at the beginning and see how serotonin is made, and once it is made, then how is it converted into these new molecules. Jiang Fang Yu, a graduate student in Schroeder's lab and first author on the paper, further showed that the new serotonin derivatives affect feeding behavior. When the worms lack endogenous serotonin, they tend to move quickly across the bacteria food lawn on an agar plate and turn infrequently to explode the food used. We found this behavior can be elevated by treating the worms with serotonin derivatives, suggesting these newly identified compounds contribute to effects previously attributed to serotonin. The worm C. elegans is an excellent model for studying serotonin because the compound molecule signaling pathways are highly conserved across species, including in humans. For example, the researchers showed that in C. elegans, a large portion of serotonin is made in the gut, which is also the case in humans. Schroders said there are hints that human serotonin is converted into metabolites similar to the ones identified in C. elegans. This research opened up the door for many more avenues of research in humans, said Schroders, who is also a professor in Department of Chemistry and Chemical Biology in the College of Arts and Science at Cornell University. Are the analogous metabolites important in humans? What is the role of one manufacturing pathway versus the other? How are these manufacturing pathways and metabolites important for human behaviors? Like mental health and feeding behaviors is asked. The researchers are currently exploring how the new serotonin derivative affect behavior in the C. elegans and whether similar serotonin metabolites exist in humans. So, this is the last topic of this podcast, and the last topic. Yep. As I previously discovered in many of the podcasts that we have started a newsletter providing in the information that is not easily available on the surface web. So, if you are that kind of information, please subscribe to this newsletter because uh, we need to sustain this business too, and providing you the information without any without any agenda driven website, and providing you the real information, whether it's left or the right wing. So I don't we don't care about those things, but still we will provide the information from both the side, and neither on the one side neither on the another side. So please subscribe to this newsletter to sustain this business model and this business. And yes, we will provide the new website by few by few days, in in coming days. So don't worry about it. And I know there has been not a lot of people, uh, I mean, we me and one other person, yes, have taken all this responsibility, because that's why we're not able to get into those organizational form, and we need to do things. We need to build up the team. So yep. So we need money to sustain this business model, of course. And as we all know that be done in the server. So to sustain that cost or maintenance cost, we need your we need your help. So that's it for you guys. Thank you. Till then, stay curious, stay healthy, keep researching.